Hello everyone, welcome back to S.L. Academy. Today I am going to explain about cell sort algorithm, which is improvement of insertion sort. In this video we will understand what is cell sort is, why we need it, how the gap system works, the step-by-step examples, Java implementation, and how it is different from insertion sort. What is shell sort? Shell sort is a sorting algorithm that works by sorting elements that are far apart first and then gradually reducing the gap between elements. It is considered as an optimized version of insertion sort. The main purpose of cell sort is to reduce the total number of shifts that happens in insertion sort when elements are far from their correct positions. Then, why do we need shell sort? In insertion sort, when a small element is at the end of the array, it has to move step by step to the front. It makes the algorithm slower for large lists. Shell sort improves this by allowing elements to faster using gaps. So instead of comparing neighbors, we compare elements for parts first. Core concept. The core idea of cell sort is very simple. First, we divided the array into sublists using a gap. Then, we apply insertion sort on each of these sublists. After that, we reduce the gap of the sublist and repeat the process until the gaps becomes 1. Then, gap sequence. For an array of size 8, a gap sequence would be first gap 8 divided by 2, then 4, then 4 divided by 2, then 2, then 2 divided by 2 is equal to 1. When the gap becomes 1, the algorithm behaves like an insertion sort. Next slide, step-by-step example. Let's take this array. 23, 12, 1, 8, 34, 54, 2, 3. With gap 4, we compare 23 and 34, 12 and 54, 1 and 2, 8 and 3. After sorting those pairs, the array becomes 23, 12, 1, 3, 34, 54, 2, 8. Now gaps become 2. We sort these sublists 23, 1, 34, 2. Then 12, 3, 54, 8. After sorting, we get 1, 2, 23, 34, 3, 8, 12, and 54. Now gaps become 1. And the final insertion sort gives 1, 2, 3, 8, 12, 23, 34 and 54. Then Java code. Here's the Java implementation of shell sort. The outer loop controls the gap starting from n divided by 2 and dividing by 2. The inner loops apply insertion sort logic each gap, and this allows to element move faster towards their correct positions. Test the code. When we run this code with our example array, the output is 1, 2, 3, 8, 12, 23, 34, 54. This confirms that cell sort works correctly. Cell sort versus insertion sort. In insertion sort, we only compare adjacent elements. In cell sort, we compare elements far apart. Cell sort is faster and more efficient for medium-sized arrays. Then, advantages and disadvantages. Cell sort is faster than insertion sort and easy to implement. However, it is not stable and its speed depends on the gap sequence used. Conclusion. To conclude, cell sort is a powerful improvement of insertion sort. It reduces unnecessary movement by using gaps, making it much faster for medium-sized datasets. Thank you for watching. If you found this useful, share, like and subscribe.